Right, let's take a look at nuclear symbols. So nuclear symbols are like the tiny square boxes that you see making up the periodic table. So in the periodic table, we have elements that are made out of one type of atoms. So we have elements like lithium, oxygen, carbon, what else is there? Gold, silver. So these are all arranged in these tiny boxes within the periodic table. Now we'll look more in depth into elements and what they are in future videos, but today we're going to focus on the periodic table and the nuclear symbols that make up the periodic table. So if you look at the periodic table, you'll notice that it has letters. So these letters are the elemental symbol. So this means oxygen, and this means lithium. So more often than not, these letters will be like acronyms, or they'll at least sort of resemble the element they represent. So oxygen for O, right? Lithium, Li for lithium, right? But sometimes it'll be different. So there'll be like Au and Ag, gold and silver. So it can be quite confusing, but more often than not, it's pretty easy to know. So lithium and oxygen. Now, we have the bigger number and the smaller number. So this can actually sometimes be written as Li, 3 and 7. I noticed this with more American stuff, but it should be 7 and 3 in your periodic table, but it can be flipped around. So just don't remember it as the top number and the bottom number. It's always more useful to remember it as the bigger number and the smaller number, because it may be flipped like so in your exams or whatever you may need it for. So oxygen and lithium. So the bigger number on top, this is what we call this number over here. This is what we call the mass number. So the mass number tells us the number of protons plus the number of neutrons. So it's the total number of protons added to the total number of neutrons. That is the mass number. Now the number below it, that's the atomic number. So that's this number, the smaller number. The smaller number is the atomic number, and the atomic number, so this is the mass number, and the atomic number, so the smaller number represents the number of protons. So the mass number, the bigger number, tells us the number of protons added to the number of electrons, protons added to the number of neutrons. And the atomic number, the smaller number, tells us the number of protons. So it makes sense that the mass number, the bigger number, is protons plus neutrons, right? Because it's added. Not only is it the proton number, but it's added with the number of neutrons. So it has to be bigger, right? So the mass number is always bigger. It can't be smaller because that's not possible, is it? So the mass number is protons plus neutrons, the bigger number. And the atomic number, the smaller number, is the number of protons. So that means that if you want to calculate the number of neutrons, we can just minus the mass number from the atomic, right? The bigger number minus the smaller number. So lithium has 4 neutrons. Oxygen has 16 minus 8, so 8 neutrons. So just minus the bigger number from the smaller number to calculate the number of neutrons. Because the bigger number is always the proton plus the neutron number, and the atomic number is just the number of protons. What about electrons, I hear you ask? Well, electrons, the number of electrons is always equal to the number of protons. So the atomic number, you could think of it as atomic number is also equal to the number of protons. So this atomic number represents the number of protons, and the number of protons is always equal to the number of electrons. Except when we do our electron configuration, where electrons can lose or gain electrons so that it can have a full outer shell of electrons. I explained that in the previous video, but at least what it is in the periodic table is that the number of protons and the number of electrons in its default state is always equal. So from just looking at the periodic table, the nuclear symbols, we can tell that lithium has 3 protons and 7 minus 3, so 4 neutrons and 3 electrons. Because the number of the atomic number, the smaller number, is always equal to the number of electrons and protons. And to calculate the number of neutrons, which is minus the mass number from the atomic number, because 7 minus 3 is 4, so 4 neutrons. Because the mass number is the number of protons added to the number of neutrons. Okay, and also one more thing to know. The number of protons determines the type of element it is. So notice lithium has 3 protons and oxygen has 8 protons. Fluorine has 9 protons. So the number of protons determines the element. So there's no two elements with the same number of protons, because that is what determines the type of element it is. So the number of protons and the electrons are always the same, and the atomic number, the proton number, determines the type of element it is. The mass number is always larger than the atomic number, because it consists of both the protons and the neutrons added together, whereas the atomic number just consists of the number of protons. So an atom with 3 protons will always be lithium. If an atom has 8 protons, it will always be oxygen. If an atom has 9 protons, it will always be fluorine. So to summarize, the number of protons is the smaller number. The number of electrons is also the smaller number, because the number of protons and electrons are equal. And the number of neutrons is the bigger number, the mass number, minus the smaller number, the atomic number. So in this case, it's 4 for neutrons. I hope this makes sense about the nuclear symbols, and I'll see you guys in the next one.